Let's start. So let's start with what is reactive programming. To explain to you about what reactive programming really is, we'll have to first start with explaining to you what is synchronous versus asynchronous programming. So synchronous programming is when you start, when you actually hit a database and you actually wait for a response to come back. And not database, to be more specific, it can be any data source. Okay. And you wait for a response to actually return, and your threads are actually waiting in the waiting state. And asynchronous programming is where you actually send a message or a request to the database, and your database basically sends you a callback sometime in the future. Okay. So this is what is the difference between synchronous versus asynchronous programming. Now let's now what is reactive programming? So it's a paradigm for handling data from asynchronous streams using functions or handlers. So over here, paradigm means it's a method of programming. It's a way of handling data where you can handle specific data coming from various data streams which are sending you data at some point in the future in a timeline. And you handle it via handlers. Basically, you specify, okay, this is a handler and I want my data to be accessed like this, and or I want my data to be transformed in such a way. Now, when you're doing a reactive programming, or one thing which we need to keep in mind is we need to always program in terms of push and not pull. Generally, when you use imperative programming, you always program in terms of pull, where you are actually pulling data from an iterator or any other stream. But over here, you actually expect events to come down to you as a push mechanism, and then you react to these events or data which is coming to you through streams, basically. Okay. Now let's dive into what reactive programming is and what it is not. Actually, I actually want to know. I actually want to tell you what reactive programming is not. So reactive programming is not the same as reactive systems. Basically, people confuse themselves saying between these two terms, basically, reactive programming and reactive systems. So reactive programming is computing using ephemeral data streams, whereas reactive systems is coordination of distributed systems focusing on elasticity and resilience. Okay. Now, reactive systems is more of a distributed concept where you coordinate between different machines. You aim for elasticity and resilience. But reactive programming is more of a single machine concept, basically, where you are mainly focusing on short-living streams, basically transferring data from one thread to the other or one end to the other end from the data source. Okay. Now, RxJava is an extension of the ReactiveX project, and ReactiveX project is was actually made for extending this reactive library to various languages. Okay. Now, RxJava is one of the extensions. There are a lot of other extensions like RxSwift, RxJS, but we will not be covering that in this specific tech talk. Anyways. Okay, so RxJava was first created by Netflix in 2014, and there are a lot of other companies using RxJava currently also. Anyways, okay, so let's go with the next slide. So we've been talking about what RxJava is. Now let's talk about what are the basic building blocks of RxJava. So there are something called observables. Observables can be referred to as streams. We'll talk about what they are in more details. I'll just tell you what we are going to cover and what are the basic building blocks right now. There's something called single, completable, maybe, and subscribers. So observable, single, completable, and maybe, the first 4 points are basically what you can call producer in a producer-consumer model. And subscribers are what you call consumers, basically. These guys basically consume data from a specific stream. Okay, let's dive into each of these topics in more detail. So what is an observable? So in reactive terms, right, observable is nothing but a stream. So think of yourself standing in front of a river bank, basically. Okay. And there is a factory, wood log factory upstairs somewhere in the uphill, basically. And this log factory wants to transfer all the logs of wood down the hill, basically. So what is the best mechanism for them to do it? Is basically like, they can push the logs through this water stream, which is flowing through the river, and then collect it somewhere else. So basically this water which is flowing from the uphill to the downhill can be considered to be a stream. A stream can have any number of events or data or no events at all, basically. Okay. And it's not necessary that, there are always subscribers to a stream. One thing about RxJava is it only executes, or, it only, it has lazy execution, basically. It only executes when a subscriber is actually subscribed to the specific stream. Till then, it does not execute any of the data sources, basically. And so what is an observable? Okay. So like I said, it's just a stream. Okay. So you can create an observable using the create function in an observable class. And there's also something called an onNext operator, where you can actually push data in whatever object you want to pass to. You can actually call the onNext and pass it. There's also an onComplete method, which will mark the completion of a specific data, set of data. Basically, you want to notify that the subscriber, you want to notify to the subscribers that the data is completely sent, and everything is done, and subscribers can stop subscribing to this specific stream. Okay. So onError is a function which is called whenever we see an exception handling occurring. So basically, it's a way of RxJava to handle the error, okay, and pass it upstream to all the subscribers to notify them that so and so retrieval or a function returns so and so error. Okay. Okay, so that's all about what is an observable. We'll go with what is a single. So single, you can consider it as a type of observable, maybe. Okay, it is mainly used when only one item needs to be emitted. Okay, so like we see here in the first point, single is an observable which only emits one item or throws an error. Okay, it is used when we do not want to collect the data emitted into a list. Basically, on contrary to the observable, where we actually collect a list of data and then perform the collection operation. So single, the difference between a single and an observable, you can consider observable as a list of singles, probably. All right. When you do a flat map on a single object from an observable, you actually get an observable object in return. Okay. So on success, you actually, if you can notice here, you don't have the onNext, method like you had in observable, because over here, since it's a single object which you're emitting, you will only have on success and you can only emit one data. So that itself marks the completion of your data passing. And we also have something called onError method, which will basically send the exception like an observable to all the subscribers, notifying that our database has caused an exception in so and so ways. Okay, now let's move to what is completable. So completable is also a type of observable. Basically, it is only used to signify the completion of task or an exception happening if the task did not occur properly. Okay. So completable has two functions, basically. One is onComplete and the other is onError. And the onComplete method is used to signify that the task has been completed. And the onError method is used to signify that the exception has occurred. Okay. And we can similarly propagate the exception up to the upstream subscribers, basically. Okay, so till now we have been talking about data streams and observables and all those fancy terms. Now let's try to find out what is a data stream, basically. Okay, so data stream is nothing but data emitted at any point of time from a subject. Now a subject over here is basically a producer in a producer consumer model. And to give you a better example, I have a small animation here. And this line actually represents a timeline, basically. Okay, and you can if you see over here, And the numbers you see, the integers you see are basically data being passed. Okay. And this data can be passed at any point of time in a timeline, basically. Okay. So this is what is a stream. When the data, the mechanism of passing data through a specific timeline, it's not necessary that all these data will be visible to you at the same point of time as the stream is emitting or the data source is emitting. Okay. Depends on the observer. Basically, the observer will obviously have get the data in totally different asynchronous manner, where maybe you can get 3 first, and then 1, and then 5, and then 4. Okay. So now we'll talk about what are the reactive operations on a stream. Okay. So we have streams. Okay. Let's say we have a stream of data. Okay. That is emitting numbers from 1 to 8. Okay. And here we have something called a filter operation. Okay. And this filter operation does nothing but takes all those numbers divisible by 2 and passes it to the subscribers. Okay. Now over here, filter is one of the operations. There are many other operations like filter, map, flat map, etc. We'll be talking about them in more detail in the upcoming slides. Okay. So this is the subject which is creating the stream. Like we are seeing, the first line is a subject. And here comes the observer. The best thing about RxJava is there doesn't need to be just one observer. There can be multiple observers too, basically. And about what are all the other functions available, there's a map function, there's a flat map function, there's a count, distinct, and delay. Okay. You can actually use all these functions to manipulate the data coming out of the stream. So I just gave you an example about how filter works. You can, a map will probably do a transformation and give you the data in a totally different form. About what, you will have to write the logic for that using handlers. But okay. So these are these are some of the operations on the stream. There are a lot of other operations also. So let's talk about how an iterable works in an imperative world. So for an iterable to work, we first get an iterator first, and we use 2 functions basically. One is the hasNext function and the other is the next function. The hasNext function implies if the iterator has more elements inside it, so that you can use it in using the next function. And this is mostly pull based, where you're pulling data from the iterator, and this is mostly synchronous. Okay, here I have a reference to the class. Anyways, okay, so iterable versus observable. Now that we have seen what is iterable, okay, now we'll compare an iterator and an observable and see how these two are different, how we use these two differently in the real world. Okay. So for an iterator, we first get an iterator, but for an observable, we first subscribe to an observer, basically. All right. This is the first operation we do. Okay. And for an iterator, you do a hasNext and next operation. On an observable, you do an onNext and onComplete operation. So hasNext basically, this is what hasNext basically gives you probably how can I say this? Okay. hasNext will give you a boolean saying that an element is present or not in an iterator, and the next will actually pull the data out. And over here in an observable, you have onNext, where you can actually push the data to all your observers, sorry, all your subscribers. So in that way, an iterator is pull based and an observable is push based, and an iterator is mostly synchronous and an observable is mostly asynchronous. All right. So let's move to schedulers in RxJava. RxJava also provides some concept called schedulers, basically. Okay. And by default, RxJava is single threaded. Okay. And schedulers basically help to run the task in the background threads, where you do not want your main thread to be, handling all these synchronous events or asynchronous events, and you do not want your main thread to be blocked, basically. All right. So there are 2 places where you can use schedulers. One is observable.observeOn and observable.subscribeOn. So observeOn is where you can tell everything downstream below a specific stream, a specific line can occur in a specific set of executors. And subscribe on is where you say everything upstream above from where the data is being emitted can actually occur on a specific set of executors. Now we'll talk about what are all the executor services available in the upcoming slides. So we have different types of schedulers. Schedulers are nothing but executor services. So we have something called schedulers.computation. We have schedulers.io, new thread, trampoline, and from. In from, you can actually pass the scheduler, executor type you want, basically executor service. And in schedulers.computation is mainly used for computational purposes where you have compute intensive tasks. And in IO, you actually pass all those IO intensive applications where you are handling synchronous DB calls or any data source calls. New thread is used when you want to spawn a new thread every time a new you want executor service to handle an event. Okay. And trampoline is where you want everything to happen in a linear fashion, where you actually want all your data to be handled or executed, all your functions to be executed line by line. So since trampoline has a single thread only, it will only execute in a sequential manner. Okay. Now that we've seen some of the concepts, let's see a real world example. Okay. Now let's assume that we are working on a new service and we have the following requirements. We need to do a search for a query in the search server, and the search server will return some IDs. Okay. Let's say we have a third party search server which will return you a list of article IDs basically. And for each of the article ID, we load the new articles from the DB. And for each ID, we find out how many likes the article has and merge the results from above two steps and send it to the view layer. Okay. Now this can be done in multiple ways. Let me show you one of the ways. So for all these to occur, let's assume that we have so and so APIs. So one of the APIs is called search article IDs, and this takes a query in as an input parameter and gives you a list of integers as IDs. Basically, these are all the article IDs. And we have something called get article, and this takes an article ID and returns you a article object itself, which will contain all the article information. And we have a get like count, which will actually hit a different repository itself and get you all the like counts of a specific article by article ID. So we respond with the below object called article info, basically. Okay. And so this object is returned back to your view layer, basically. So this article info is nothing but a combination of article and like, basically the number of likes. So what is the general way of solving this? I mean, it's in an imperative, world. This is how we solve this solution of providing article view info to our subscribers, basically. Okay. So first you get the article IDs using a list of articles. Using a query. Okay. And then you create an empty list, and then you iterate through each and every article ID, and then you first get the article, and then you get the like count for the specific article, and then you create an article info, and we emit the result out to the subscribers. Okay, so this is interesting. And so do you see the problem with this code? I mean, like, there is obviously this one way of solving it. Okay, this code will run and everything like that, but there's a problem over here. So there's no concurrency involved at all, first of all. So it's all sequential. We are doing a search, then we are doing a get, and then we are doing a like count. Okay. And as you can see, right, this the total time is a concatenation of all those repository times. Maybe your get is taking 2 seconds to respond, or a like count is getting 2 seconds to respond. That will, so if you are having around 10 IDs which you are emitting from the search server, so a combination of all these to occur in a way, it will take you around 40 seconds completely. So since get takes 2 seconds and like count takes 2 seconds. So this is why sequential is not fit for all the scenarios. So when we are fetching an article, nothing prevents us from fetching the like count concurrently or even loading another article also. So we don't have to actually wait for the next article to be loaded or the concurrent like count to be received from the parallel server. Okay. So when you execute this using concurrent processing, you see all this yellow line is basically a search, okay, and the red line is a get, and blue line is a like count, and obviously this will all run parallelly, and you can already see from the diagram itself how the total time will be reduced to around 2 seconds or even 3 seconds. In any ways, it's still a huge profit in terms of time. And one thing to notice over here is the task which takes the highest time will be the task which will define how soon you retrieve all the operations and your stream is actually emitting all the data to the subscribers. And another thing to notice over here is the search operation, no matter what you do, cannot be parallelized, because that is the first source of data which you are getting from the search server. Okay. So that is something which cannot be parallelized. Everything else, as you can see, get and like counts can all be parallelized for every single ID. So when you use RxJava to solve this, right? As you can see, your search article IDs is returning an observable of integer. So this will be a stream basically. Instead of it being a list, it is now a stream. By stream, I mean observable. So next, what we do is we get the article IDs, we do a flat map, and then for every article ID, we get an article and we get a like count basically. Okay. So we zip it along with the like count, and for every article ID and like count, as you can see, this is a zip with function which will combine the article and the like count together, and we create a whole new article info object, which we will forward it to the view layer. As you can see over here, article and like count are both wrapped around a single. Previously, they were just plain article and integer objects. Right now, they are wrapped around a single, since it's a stream also. So we return an article infos back to the subscribers. So enough about all this talking and about all these technical terms. Let's run some Rx code and see how we can, leverage this library. Okay. So this is an application. Okay. This is an example about what we spoke about some time back about retrieving all the articles. Okay. So as you can see, we have two repositories over here. One is the article repository and the other is the like repository. Okay. Now, article repository has two methods basically: search article IDs and get article IDs. Okay. So search article IDs takes an article search query as an input, and it returns an observable of IDs. And get article ID basically gets one article ID and returns a single of article. All right. Now, if you can see, so here I have not actually created the, I'm not hitting the backend to a database for the sake of brevity. I am just returning a list of array. Okay. And this contains 10 IDs. All right. And the get article, on the other hand, is actually mocking a delay. Let's say that this is a database call and it's mocking a delay. And we are emitting an article for so and so article ID. Okay. And this creates a whole new article and then returns it. But there's always a delay over here. Okay. And similarly, in the like repo, we have something called get like count. Okay. And here also there is a delay, like we spoke about. There's a 2 second delay. And we are creating an like based on a random integer. Okay. Like I said, I'm not hit the database or for the sake of brevity, but let's just assume that this is a database call. All right. And so when you are running this application, okay, logically when you run this application in a real world, okay, or an imperative world to be more frank, right? It will take you around 40 seconds. But as you can see, the magic of RxJava, this takes just 2 seconds to execute. Now, let me walk you through where the magic actually happened. Okay. So over here, you can see there's something called schedulers.io where we are subscribing on. All right. So everything which happens within this create method actually happens in a background thread, an IO background thread, basically. Okay. And over here, this emitter is emitting a specific article on success. And this whole operation of emitting and everything will happen using a background thread. There are, like I said, there are a lot of other schedulers also, computation and all other schedulers. But here I've used IO. Okay. Yeah, no problem. You can definitely ask. So computation also works the same way. Okay. So what happens when you use computation instead of IO? So computation also works the same way, basically. So computation also works the same way. It's just that, IO is more designed to be more IO oriented, and it is designed to wait for all those tasks. Computation is not designed for waiting, basically. All right. Yeah. Yeah. I'll get to the part where okay, so let me go back to the code. Okay, so this is not the actual subscribe operation. Okay, so subscribe operation is where this is the subscribe operation. Okay, where we are actually making the subscription calls, and each of the subscribers printing its own value over here. If you can see, right? Article view info, and article view info. This is from subscriber 1, subscriber 2, subscriber 3. Let me show you the run. Okay, where you can actually see what they all printed. As you can see, right, they all printed the same values. All right. Now you can actually parallelize this operation of printing also using an observe on. Like I said, everything downstream happens using an observe on operation, but I'm not user right now. Okay. So let's go back and let's remove the magic out of this code. Okay, and see what happens. Sorry, 1 second. Sure. So one of the questions, can you explain more about scheduler IO? Yeah, can you explain more about scheduler IO? Okay. So scheduler IO is okay. So one of the questions is, can you explain a little bit more about scheduler.io? Okay, scheduler IO is an executor service, basically, created by provided by RxJava itself. And so when you want to do basically a synchronous call, okay, to the DB, and your threads are basically waiting in the backend, and when you want to create an what you do when you want to create an executor services, you create an executor service, and then you provide all these threads to wait at a specific time. Okay, so that is what is happening in schedulers.io, whereas computation is more of a computation oriented executor service, where all the computation occurs through these threads in the computation service. So IO is mostly designed to wait. Okay, whereas computation is mostly designed for computation oriented tasks, basically. Yeah. Okay. Yeah, it'll return you something. Whatever you wrote, the logic of the handler is what it is going to return. All right. Yeah. How DB calls can make use of it. Okay, so when you're calling a DB, basically, your DB will return you a specific object. Now you emit this object through a specific emitter. Let's say a single object. Over here I have used. Okay, so let's say this object is basically an article ID, and I'm returning a like count over here. Okay. So how DB can be can use this is basically when, let's say this is a synchronous call, okay, and basically your synchronous call, you do not want your main thread to be waiting, basically, right? So you are delegating this operation to a background thread, and this thread actually makes the whole process of waiting for the DB to respond synchronously, and then return a call back to your main thread saying that this DB has retrieved so and so data, and that's the way the control is passed around. Are there any existing libraries for DB calls in RxJava? Actually, okay. Are there any existing libraries for DB calls in RxJava? Actually, I have not come across any of the existing libraries yet. Okay, I'm not sure about any existing DB library which is present in RxJava, which specifically provides a reactive object as a return type. But they all provide a future, so probably a completable future. And RxJava gives you a mechanism to wrap around this future using an observable. So that's one thing. All right. So now that we removed the whole magic out of here, okay, let's run this code again.
Yeah, there's a comment on the chat. R2BBC can be. Yeah.
Okay. There's a comment on the chat which says that the R2BC can be used for reactive Java. Yeah. So as you can see, once we have removed the whole subscribe on method, we can see everything happening sequentially. And so this is one after the other. There's no concurrency involved at all over here. So obviously, RxJava is helping us with performing the concurrent operations more easily. Obviously, there are a lot of other ways also to perform the same concurrent operations. It's just that RxJava makes things more easier to write and read. And instead of us handling all those future objects and handling all those callbacks in a very lower level, this is just an abstraction on top of that, basically. Okay. So with that, yeah, please go ahead. Sure. So like I just told you, right? So this is application. Okay. Like I said, there are two repositories over here. Okay. And let me walk you through what an article repository does. Do you want me to go there? So it has two methods, basically: search articles by IDs and get article by article ID. Okay. And we have search article by article ID returns you a list of article IDs. This is hard coded for the sake of brevity, like I just told you sometime back. So this guy returns a list of 10 IDs. Let's say these are 10 IDs. Okay. This is the observable.from is one way of creating an observable. If you already have those values already with you, okay. But when you are trying to emit something, you always use something called a create method on an observable, like I have used for a single over here. Okay. So this method get article over here is mocking a delay from a DB, basically. Okay. And we are emitting a new article basically from here. Okay. For a specific article ID. So over here we have something called an emitter, which we call using the onSuccess method. This onSuccess takes a input argument as the data which we are trying to pass. Okay. And this emitter.onError is where you are actually trying to pass the exception if in case anything occurs, and you propagate that exception upwards. All right. Similarly, there is also something called in like repo also there's a method called get like count. Okay. So this guy is also mocking a delay of 2 seconds. Okay. And we are emitting a like. Basically, this is basically a random integer. Okay. And here we can also see the same emitter.onSuccess and emitter.onError being called. All right. So going back to your application. So we have these two DBs. Now, first you make a call to get to search articles by article IDs. Okay. Where you actually pass an article search query. Okay. And for every one of the article ID, okay, what you do is you first get the article by article ID. So this is a single object. Okay. And you zip it along with a like repo.get like count. This will be a like, and this will also be a single. So you zip two singles basically, and you create. And what RxJava gives you is a handler for you to actually handle these two objects together. And you create a whole new article view info object and return it back to your stream. Okay. So here I've used a flat map single because a list of singles are obviously going to be an observable. Okay. So that's why this is returning an observable of article view info. If I did not use a flat map over here, this will be an observable of single of article view info. We do not want that. So this is a flat map single. That's why RxJava has given you something called flat map single instead of just flat map. Okay, where you want to convert a list of singles into a observable object. All right. And then we have something called do on completed. This will actually execute once all the operations of the observable have been completed. Okay. And then also there is something called a cache. Okay. The reason I've used a cache is because I do not want to perform the same operations of retrieval every time a subscriber is actually subscribed to my event. Yeah, if I don't use a cache, the whole event will occur again. Basically, he will go and retrieve the data and. Okay. Yeah. Yeah, but the whole operations after that will occur again. We do not want the operations to, the emission will happen just once, but the operations will occur again and again. So we do not want that operations to occur. So that is why we are trying to cache that operation over here. And then, so if you remove this cache, this will all occur again and again and again. That's what will happen. So we have 3 subscribers. Like I told you, there can be multiple subscribers over here. Okay. Here I have added a thread of C just for, so my console is still on since it's mostly asynchronous. None of this will happen. This is all lazy. Okay. All right. Are there any other questions, guys? So, okay. Can you repeat that? No, I want her to repeat that first. Yeah. Okay. Yeah. So when it's an observable, like I said, it's just a stream, right? It's not like a stream is going to end. Now, like I said, a stream can contain any number of data, and it can contain no data at all. It's like a connection you are creating between your backend and your subscriber. Okay. And just because there's no data does not mean that the stream should end. Maybe the data can occur sometime in the future. Now imagine that you're consuming from a queue system. Okay. Let's say you have a queue and there's some data which is falling under your queue. Okay. And this queue is emitting data to your backend. And that is what you're trying to propagate all the way till here. Okay. And since we don't know when the data will fall into the queue, it is not wise to close the stream beforehand, right? We know that when there is 4 or 5 data coming together, okay, that this is the end of data for the current time. That's all we know. Okay. And then we can probably mark a completion of a data sending event. That's all. We cannot close the stream itself. So when you are using a subscribe method, this is an ongoing process basically. All right. So I hope that answered. Yeah. So you wanted to. So the question was that, what if once we call the subscribe method, the stream will itself close? That was a question. So I hope that answered your question. Right. Sure. This subscribe. Yeah. Yeah.
I assume it's just shorthand for next. Right? It's not. There is no error in complete. It's probably some method.
Yeah, so there this is just a very small implementation of a subscriber, like you said. So when you actually write a subscriber, there will actually be 3 methods, like you said. One where you can handle the exception, one where you can handle the data, and the other yeah. So I just wanted to give a very small example. Okay. But anyways, over here also the exception will be propagated. It's just that the subscriber will be informed of the exception. The notification will still happen. All right. Okay. Let's if there are there any questions in the chat? Okay. Okay. So these are some applications of reactive programming. Retrieving data from a database, filtering on the stream. Okay. And rendering a UI that combines data from multiple data sources. And we log data from temperature, pressure, and wind sensors. So I see that reactive programming has mainly been used for logging data from sensors, basically. Whenever there was an Arduino type of a project where we are trying to, send data over sensors, and it's a two-way connection and a long-living connection, and there's just data coming in, and we don't have to send requests to get a response. That time we actually see RxJava or RxJS or any type of reactive programming concepts being used widely. So while rendering a UI also, it is not wise to wait for one element after the other. So obviously all the elements are loaded parallelly. So that is where RxJS is generally used. And retrieving data from a database and filtering on the stream is something which I just showed you an example of. Anyways, with that, I will end this tech talk. I thank all of you for visiting, and it's been a pleasure. Thank you everyone from Sahaj for giving me this opportunity to host this event. Thank you.